welcome back.
Hello, Luca, and welcome back.
So, it's been a crazy week last week, and finally we have some time to breathe
Yeah,
and to
well,
talk about what we launched.
we launched a lot.
So, let's start from the beginning, why we build it. And
Oh, but what we launched?
yeah, it's also in the why. So, last week we launched uh, VAT for agent ecosystem, which comprises of one component open source, Regina, and then something only for enterprise, that is how to run these agents in coordination and inside of Kubernetes, plus the Sandbox. We launched the most hipster stuff that we could have
Well,
launched.
everybody is working on a sandbox these days, so we couldn't, avoid it, and we needed to
No,
try
but
and try our take on this problem.
but I think what is completely different is the philosophy behind. Like
Of
we
course.
we saw when we built VAT, we were actually on the quest of answering the eternal question: can we build a universal primitive for running modern JavaScript in enterprise? And we spoke with Tanner at the end of the conversation with him about the kind of like long-term vision. And the point is, if on one side we want to enable what we call developers creativity, we want to enable operational freedom. And so what we needed is something that would basically harmonize all those functionalities needed to build modern JavaScript applications. So they go from the web to the backend, and now not only because we build it, but the economy is the one of agents. So that was kind of like the journey we went through. And like I said, we focus on what is the developer first experience with the local development and run with Regina. But then at our heart, that's the answering always the question how to run it in Kubernetes for the modern enterprise, because we know that the enterprises are also on the quest of this agent or agentic evolution, right?
To be clear, every single one of them that we have talked in the last maybe 6 months, okay, maybe even less, okay, is on a quest to try to streamline the use of AI in their organization across all functions, okay, and this means bringing a lot of agentic or autonomous behaviors straight into the hands of people, of employees, not just developers, not just coders, okay, but throughout the whole org.
Yeah.
In a lot of sense, this is what a lot of people have been. Some people have tried to do with using OpenClaw with AI in for company stuff, okay, but OpenClaw has some it's very good for personal as a personal assistant type of thing, a little bit more tricky for as a deployment mechanism. Oh, how do you deploy it? Oh, you take a Mac Mini, okay, and you install it on your desk, okay. It's not that straightforward. So how
Well,
do you roll it out across a company?
yeah, well, we didn't build a new OpenClaw. We stay far away from building a new
Yeah.
OpenClaw. But maybe let's deep dive on. I want to start and tell more. Let's go more in details of what Regina is, and then we fade into the problems of running such a system in Kubernetes, how we solve it, and then we talk about the
Yeah. So
sandbox at the end.
what we've done with Regina is so we have the with what, okay, we have the concept of running independent Node.js applications as worker threads, okay, or as processes. With Regina, what we saw was, well, anything of these new agentic system is just a node process. It's just a node app, okay? That needs to have some timers, some external events, some external stimuli coming in and reacting to those stimuli. So to be honest, this is just a node app, okay? Now, there is a catch, okay? We want those node apps to be able to evaluate and create their own software to some extent dynamically. This is like a very popular, a very important thing for AI. So anyway, what we've done with Regina, okay, is a new set of VAT capabilities that allows you to define your agent as a combination of Markdown and TypeScript files, where the TypeScript files contains the tools available to the various agents, okay, the individual agents, okay. Each agent can just talk to each other, okay. So you can, an agent can require another agent. Oh, I need to send a message to that agent, okay. Each of those agents are, there is an archetype, okay, and then they are instantiated, and you can have multiple instances of that agent running. Imagine that you want to have multiple users on your system, each one have their own agent or session, and that include state, but also what? Okay, there is the state, which is, and the context, okay, but what is the state? Okay, the state is essentially based on the, typically, for a lot of these things, based on the file system. So we have took, in the open source version, takes the Just Bash tool from Vercel and mount it on top of the virtual file system that we launched a few weeks back, okay? That hopefully, finger crossed, is coming to Node soon. And at that point, okay, what we do, we can persist that state and maintain that state of that file system and of that Just Bash instance inside a SQLite file. And that SQLite can be easily stored, moved around, and manipulated. So with this combo, we can essentially encapsulate each agent in its own little thread, and they can communicate with each other. They can do all sorts of things. Okay, and yeah, it's open source. You can try.
So when you say, just to explain to everyone, like that you write the agent in Markdown, who is then the provider that is gonna resolve that Markdown?
Of course. So the key part there is you need to provide a configuration to Regina for your an AI gateway. We use the AI SDK underneath to provide multiple support for everything. So you can just use the AI SDK to. We can
Again,
just
from Vercel.
Yes, of course.
Guillermo,
Okay.
send us some goodies because.
I want to know. I need Vercel. So I have a Vercel blanket, Luca. I have a Vercel blanket. I need more Vercel swag. Okay.
I have plenty of black T-shirts, and I thought they were all branded, but they're Lululemon, but they're similar.
So good. So yeah, it's great. Okay, it's let's see. I want to know what you think about it.
Yeah, but let's go a little bit more kind of like on what is the use case of building such a thing like Regina, or what kind of like problem can humanity solve with Regina?
Well, to be honest, the real reason we built it, okay, is as a starting point, was as a development tooling for our enterprise set of features. Okay, essentially, you want to be able to manage agents at scale. Okay, and Regina provides the building block for doing that because it provides a way to take the context, move it around, store it, and do all sorts of things like that. Okay, and it's open source and you can try it. Okay, but the real feature is the part of our enterprise solution.
Yeah, but like okay, so let's then jump into where is the problem with running agents in a system such as Kubernetes.
Yeah, that is the key. That is the key question. Okay.
So let's start with the problems and why we actually went there.
So the problem, there are a few problems. Okay. The fundamental problem of an agent, okay, is that it's ultimately stateful and very stateful. Okay. It has state on disk, it has a state on memory, it has state on connections. Okay. It's essentially the exact opposite of everything that has been taught in the last 20 years to software engineers. Okay. It's essentially, it's taking all the field of software engineering and putting it upside down. Okay. And most companies, most people do not understand how complex this is, to the point of, oh, what is the best way to deploy an agent? Oh, you buy it a Mac Mini. Okay. Because it's literally the simplest thing you can do. Okay. Doesn't scale, but that's a way to do the thing. Okay. Now, the fundamental problem with an agent is that you need to in a system like Kubernetes that is fundamentally built to be stateless, okay, or ephemeral, okay, where a node is ephemeral, node can come up and down, and I need to be able to recreate and update it and change it, is how do I manage that state? So I need to be able to take the state of my agent and serialize it, store it somewhere, and then unpack it somewhere else. But more importantly, if somebody wants to talk to my agent, if I want to talk to my agent, I need to know exactly to which in which node it's running, okay, and in which pod it's running, okay. And that is very tricky because in most Kubernetes systems, you are essentially horizontal. It's horizontal scaling. So you don't know which pod you're talking to when you're sending a request to a load balancer. So then you see it's taking all the system upside down in term of in term of how this kind of system is built. The fundamental point and one of our and one of our inspiration was to some extent the DynamoDB paper, and in part, okay, not because we implemented an hashing or anything like that, but as a way to handle state, okay. And what we have done in order to do this properly, you need to have essentially a coordinator or an entry point or a gateway, or you can call it the way you want, but you have a coordinator system, which is cool, okay. And the coordinator then knows all the pods, all the pods that are available, and that coordinator now can decide knows exactly what that given agent is running. So you need to have this sort of hard management, hard scale lookups, okay, to make sure everything works, everything is routed correctly, okay. And this is just a lot of distributed system and networking and DevOps to make sure that these things are actually deployable in Kubernetes, which is non-trivial.
Yeah, and I think on one side if you look at agents, they really look like this durable execution system, right? Because they have a non-deterministic length of execution. They can move huge amount of payload. So also the size of the state is actually a kind of like very relevant factor in this equation, right? We're not moving like cookie session in this model, that we are moving chunk of kilobytes of data that they go up and down the system. And when you mentioned the gateway, for us was very important to kind of like focus on the concept of separation of concerns, and especially something that in enterprise is a very dear, principle, that is the governance principle. Because if you think about systems that they went through this kind of like a journey, right, from stateful to stateless and back to stateful, we saw many API gateway coming into this equation and service mesh. The only problem of these systems is that they create they created, now a major question is the API concern merged with the execution concern of those agents. Can those two blend into the same type of governance? Can I cross-pollinate the responsibility of API access, API usage, and so on into the AI? And I know this is very provocative to other fellow Italian. I know that there is no AI without API, but unfortunately, the world doesn't rotate into this monolithical system, because bad news is that then you go back to MuleSoft. And I thought we actually started the journey from getting away from that monolithical approach. The reality is that our approach that we took is very kind of like provocative in the industry, because we literally wanted to build a primitive that would not cross-pollinate concerns across the other existing concerns into the organization.
Of course.
And that's actually, I think, aside from the technological challenge that you explained, there is a social political problem inside of organization, because now that we have agent who is responsible for that, if the system that manages them is the same. So that's kind of like for us the kind of thing where that's why we actually believed in the kind of like model of the Dynamo paper, where conceptually for us was extremely important that we created a separation of concerns, A, and B, we would not actually depend directly on existing infrastructure. We just say the only primitive that we can accept is a persistent storage and Kubernetes. Those are the only two things that we use, because I mean, we spoke lengthily. We could have used like a plethora of things to do this system, right? But then we create a lot of dependencies on deployment, on management, on operational continuity, and so on and so forth. So our approach has been really clearly based on what is the minimum, the most, let's say, what can reduce the amount of friction into adopting and operating such a system. And I think that, like you just said, was a crucial point into the equation, right? We go back to agents are processes at the end of the day. They're like
Agents
applications.
are processes. Unix wins.
And so Brian Cantor will be super happy that we bring back the Unix philosophy to the table. I'm excited when one day we will be able to have him as a guest. But so there is no agent. I'm gonna now troll a little bit the sentence. There is no agent without Sandbox. So let's deep dive for the next 10 minutes on.
Okay, so the other part of making this very hard for everybody is security. Okay.
Because agent can do anything by principle, right? You can tell to the agent, go and wipe my hard drive, theoretically.
Well, no, you can tell your OpenClaw to go and wipe your hard drive, because that's what is built for. Okay. Well, to be honest, it's built for connecting to your bank account. That's going to be fun.
Yeah.
Okay. And things like that. Okay. You should not be doing that, by the way. Okay. So you doing this kind of thing in a company is actually like, not even sure it's not. It's you could have some let's say legal problems if you set up things this way in your company, like because I have a feeling like if there is a significantly monetary loss, there is some personal responsibility involved at that point in time. Okay.
Yeah.
So, a little bit.
There is something that is called law that governs more than the system. So yeah, that's definitely.
Yeah, that's what I'm feeling. Okay. So so there is that. So you should not be having these kind of things running wild on your system. So you need agents that are essentially boxed in, and you want them to have clear responsibility boundaries of what they can do so that there is nothing that can do everything at any given time, okay? But you can segment it in a lot of small pieces, okay? But also you want it to be very capable. So they need to be able to create their own code and run their own code.
Exactly.
And then talk to, API, and you say, oh, talk to this API, and it just call that API, okay? And create a client from that API from thin air. Okay, this is what makes these kind of agents so cool. Okay, and what makes me very excited about this future, because you can essentially a person in marketing could very quickly create an integration between A and B just by figure it out, okay, and burning up an enormous amount of token, but the cost of doing that is always be infinitely lower than talk to a human to get that integration done. So at this point, it's actually very compelling as a topic. So I'm very excited about this kind of usage, especially not in coding, but throughout other fields, other things. But the sandbox, okay. Let's talk a little bit about the problems and what we have done. There are a lot of different options in which you can implement a sandbox, okay, and a lot of them works and not work, okay. The first point is no sandbox, okay, is 100% safe or secure, okay. This has been proven by a recent paper by our friend at Anthropic, okay. 0-day vulnerability in the kernel exists, okay. They found a security problem in FreeBSD, whatever, okay. So this kind of thing exists. So there is no whenever you take a system like this, you need to frame it against the attack, the threat model and the attack profile that you can have. Okay, so this is the first point when you design this kind of system. Now, typically agents are the biggest thing you need to protect when doing agents, okay, is against their own stupidity. Okay, in a book they were called in a sci-fi book that I read some time ago, they were called the artificial stupids, okay, because they're not really like sometimes they're not bright, okay, they make dumb mistakes, okay, and
they're like human.
Yes, well, worse than human most of the time. Yes, I wiped out a staging database, and when I was at my first job. So hey,
so there's no difference between agents and human, basically.
Yes, well, so you need to put some constraints, okay, and when and one way to do this, okay, and stop me, Luca, because I don't want to reveal too much because this is part of our product, okay. We wanted to make sure.
First of all, there are three options, right, to run sandboxes, right?
Yes.
One is the E2B model with the remote VM.
Yeah, okay, yes, of course. Yes, sorry. Let's go that. Yes. There is the E2B model that is it's a remote VM. Typically you spawn a remote Firecracker instance and you split the LLM agent from the VM, okay? This is the model that you can get very quickly started up with a lot of the providers, okay? They say...
So you have an SDK that basically create an instance of Sandbox, and then you call Sandbox dot... we saw this model execute. Exactly. We saw this model like even in Vercel, for example.
Yeah, Vercel, Cloudflare, a lot of companies are offering this model. Underneath, if you want to go a few level deep, okay, you could implement this kind of system using something like Firecracker, okay, or gvisor if you want to be more Kubernetes oriented.
So the other one is gvisor, which requires you to have a gvisor instance for your pod.
Yes.
Right.
Yes. Or which is complex, or you can just do bare bone and have it build it your own setup outside of Kubernetes completely with Firecracker. You need dedicated hardware.
No.
Is secure, yes. Making it secure, it's really hard. It's not secure out of the box. Okay, it's really hard to make.
No, but that's operational complexity, right?
There is a lot of operational complexity. So,
and then there is always the kind of like, question that is, but the enterprise runs in Kubernetes, right? You can't really go and say I deploy a new system in Kubernetes and so on. So the approach that we took had as a first class citizen of the whole solution, it has to be almost transparent from the operational process in Kubernetes, right?
yes. So I'm very excited about this design.
Yeah, we took advantage, we can say, of a kernel level instruction with
eBPF. We can say it's built on eBPF, Luca. Come on.
And we just build the whole system that manages the configuration on policies and ensure telemetry on those policies, ensures breach detection on the policy, and implements the so-called ask to get model. So we basically are able to, in a very easy way, we believe that developers should have freedom and constraints needs to be designed around communication. That's we go back to the original enterprise process that we will never kill, that people need to talk to each other one way or another, even via email. And basically we work with purely Kubernetes primitives to do that. Nothing exotic in this universe. Why we went for this approach is very simple. You just deploy an Helm chart and you're done. I don't have to maintain a new hypervisor model or a Firecracker or things that are very distant and complicated to the day-to-day of enterprise or any organization. And the reason why we didn't go for the E2B model is very simple. I need to pay for double resources to do something that I can fundamentally do with the same resource.
There is also a fundamentally different model to some extent in terms of the agent. So this is the key part. Okay, what we enable is the agent to write code that then it can self-execute from disk. Okay, and this model is really powerful.
Yeah, because it opens the door to all this agentic code, all these systems, and the opportunity of integration are unlimited. So we're not going to reveal what we are working next, which is going to be super, super cool, by the way. But we saw a great opportunity with another kind of like, AI model, let's say. Let's keep it as generic and as vague as possible. But for us, the developer experience and the kind of like ease of use was at the core. So we are excited about it. We are actually gonna is already released. We are gonna work on evolving it and add a few more features that are gonna make it extremely compelling. But we are extremely excited. We think generally we kind of like had this eureka moment on the design, and way easier, way better. Another thing that I feel we need to say, for us, the principle of isolation and responsibility was at the core. So you still have the governance through this centralized component to enforce policies. But the model, the developer model that we envisioned was like, we could potentially, developer can ask for access to, for example, I don't know, you name a URL or you name a policy on disk, And we can actually kind of like create that approval process behind the scene, which is, in our own opinion, extremely powerful and flexible for the enterprise. Doesn't enforce a prescriptive model that might diverge too much from the process that company they're already having, right? But last question, how secure is this?
So, so far we have done quite a few rounds of security analysis. So we are continuously fixing problems and escapes. Okay. We are relatively confident that all major holes have been plugged. Okay. As all these sandbox, you need essentially to test it and verify it with fire. Okay, and make sure. Okay, and we will keep iterating and working on the security of this. Okay, I'm very confident that this is good enough for the agent's use case, which is essentially protecting against themselves. Okay, and no malicious, not adversarial escapes. Okay. We have been trying several. Our target would be to be extremely resilient against adversarial escapes. Okay, and we are working towards it at this point in time.
Yeah, but I mean, I think, just not to let transpire the wrong message, is that we build what we think is the foundation of security for these agents, and we are working continuously on kind of like addressing every single escape patch, edge case, and so on. And the model that we design not only allows for a fast iteration, but for a fast patching. Like the difference
Absolutely.
between running a virtual machine or a firecracker is that you need to kill that instance and restart it to reapply policies. In our case, they can done hot directly on the execution. So that's actually kind of like the model for which we can continuously iterate and fast on the solution. But like, not to create any good enough means that we went to actually a several amount of hardening and edge cases. Is secure for the best of the knowledge, but every system.
Let me say this
can
in
be
another
broken.
way. Okay, we could not find an escape hatch. Okay,
Yeah,
let's
and
put it this way. Okay,
and we definitely, one very important thing to kind of like add to that is that a secure system doesn't exist. There's always a hack possible, and the huge amount of CVs that we are seeing and patching in other technologies every day, they are a clear testament of what we are saying. So, Theo, I think we reveal enough, but I leave the stage open to our audience to tell us if they want that we deep dive into any other further detail. Clearly, we're not going to reveal any secret sauce
absolutely.
that of our enterprise solution, but we can go as deep as possible. And yeah, with no further ado, I think we meet next week, same time, same place, with some new things. Ciao, Theo. Ciao, everyone.